In this video, we're going to see how inheritance in Java compares to inheritance in Python, and more generally, how we can use inheritance to base one class off of another. So if you remember, in a previous video, we looked at how to create a class for rectangle objects. And every rectangle object looks something like this. It had a field for the width of the rectangle and a field for the height of the rectangle. And then we also put methods inside it for growing the rectangle, finding its area, and for giving us a printable version of it. This actually is something that wasn't in the video, but we did look at this in lecture. Now, here is what the two classes look like, or at least a partial version of the two classes in the languages. And you can go back and review this in the previous video. But let's say we then wanted to be able to represent squares. We wanted to have objects for squares. Well, they're really very similar to rectangles. They are a type of rectangle. The key thing is that the dimensions have to be the same. And let's imagine that in our application, when we are representing a square, we also want to have a field for the unit of measurement. So it might be centimeters or inches or whatever it might be. And so we're going to be using two of the same fields as rectangle, but we're going to have this new field. Square objects should mostly behave like rectangle objects. So in the same way that we can ask a rectangle object for its area, we want to be able to do that for squares. And we want to do a lot of other things that we do with rectangles. But it could be that some of the behavior will be different. So perhaps when we print a rectangle, we want to see the dimensions of that rectangle. But when we print a square, we want to see something different, including information about the units of the square. And so we can do all of this without having to completely redefine everything by taking advantage of inheritance. When we use inheritance, we're basing the definition of one class on the definition of another. So in this case, we want to base the definition of our square class on our rectangle class. And we do that first by modifying the class header. So in Java, the way we're going to do it is by adding this phrase extends rectangle to the class header for our square class. And that will tell Java that this square class is inheriting from the rectangle class. In Python, the syntax is a little different, but we're again specifying which class we are inheriting from. In Java, we have to declare the fields that the object is going to have. And remember, there's 3 fields for square objects. But the only one we have to declare is the new one, the one that we are not getting from rectangle. So the unit field is a field of type string, and that's what I'm declaring here. The other fields are being inherited from rectangle. They're already declared up here, so I don't have to do that again. And Python, we don't declare fields, so that doesn't have an impact here. We then need a constructor. And in this case, we're passing in the length of a side and what unit we are using for the side's measurement. And you can see we're taking the value that's passed in for side, and we're assigning it both to the width and to the height. And we're taking the value that's passed in for unit, and we're assigning it to the new unit field that is declared right here. So that's one way we could do the constructor here, and here's the comparable Python one. And then everything else, all of the other methods, area method, grow method, they are all inherited by the square class. We do not need to redefine them. The terminology for inheritance in Java is the same as it is in Python. The new class, the one that is inheriting from the other class, is referred to as the subclass. So in this case, square is a subclass of rectangle. The class that we are inheriting from is the superclass. So rectangle is a superclass of square. Now, when we look at our constructors, we can do it this way, at least for now, because our fields are not being encapsulated, and we'll talk more about what that means in a minute. But another way we can also initialize the inherited fields is by calling the constructor in the superclass and letting it do the work. And so what it looks like in Java is, rather than having these two assignments, we're instead going to use the keyword super as a method name, and that calls the constructor in the superclass. And because it takes 2 integers, we're going to pass in 2 integers. and we're passing in that side value that was passed in to the square constructor. We're passing that side value along to the rectangle constructor. So both the width and the height are getting that value of side, and then it is initializing the width and the height for us. And we can do the same thing over here in Python, but the syntax is a little different. You may recall this from when we did inheritance in Python. Okay, now here's an example of a method that was in our rectangle class. This was not in the previous video, but it's one that we looked at in lecture. It's a toString method, and it returns a string that's going to be used whenever we print a rectangle object. And in this case, we've decided to make that string include the dimensions of the rectangle with an x in between the two dimensions. Like any other method from the superclass, it's inherited by the subclass. So the square class gets this toString method. And so if we go ahead and create a new square object, which is what I'm doing here, and we assign it to a variable sq, if we then print sq, remember it turns out that the toString method gets called on our behalf. We don't have to call it explicitly. And so in this case, when we print sq, because it has inherited this toString method, we are going to see the dimensions of the square object. And they're both the same in this case. They're both 40, which is what we passed in when we created the object. Now let's say that we want to do something different when we print a square object. We can do that by overriding the inherited toString method. And this can be done for any inherited method. You replace the inherited method with your own version by making sure that the new version has the same return type, the same name, and the same parameters as the one that you're inheriting. And if you do that in the subclass, it will replace the one that was inherited from the superclass. And so if we put our own toString method, notice the header is the same as the inherited one. And what this one is doing is saying start with the word square width, then put the width, then put a dash, then the unit, and then the word sides. And so now when we create our square object and we print it, we're going to see something different, because this version of toString has replaced the inherited version. In Java, we typically take our fields and we encapsulate them. We make them private so that they can only be accessed by code in the same class. Outside the class, you won't be able to access them directly. To provide indirect access, we add public accessor methods that return the values of those fields. And then to make sure that only appropriate changes are allowed, we put in mutator methods, but those mutator methods check for bad values. So for example, our setWidth method, which takes a new value w for the width field, and this is all in the rectangle class by the way, it checks to make sure that the width value is not 0 and is not negative. And if it is, it throws an exception, and that prevents the change from actually taking place. To ensure that bad values don't get into the object through the constructor, what we can do is replace these assignments that the constructor used to make itself with calls to those mutator methods that we've added, and they will do the error checking for the constructor. In our subclass, we're also going to make its field private, and we're going to put in an appropriate accessor method, and potentially we might also want to have a mutator method. Turns out you can leave out the mutator method if you don't think you're ever going to change that field. So the question then becomes, what can we do down here in the subclass with the fields from the superclass? For example, can we actually access the width field down here that is inherited from rectangle now that width is private? And it turns out the answer is no. A subclass has direct access to the public fields and methods of its superclass, but not to the private fields and methods. It's really like any other class in that regard. It can only access its own private fields and methods. It cannot access the private fields and methods in another class. And so you can actually think of the square object as having, it still has these three fields, but the fields that are inherited are sort of separated in a way because they cannot be accessed directly by the methods in the square class. The field called units, on the other hand, can be accessed by square methods because that's a field of the class itself. That field is defined in the square class, so even though it's private, it can be accessed by methods from the square class. So what does that mean for our toString method? It means that this direct access to the inherited with field is a problem. And that's because with is from this other class and it's private. So even though it's the superclass, it's a different class and we cannot access its private fields. So instead, we're going to have to take advantage of the getWithAccessor method, and down here we'll replace the direct access to the field with a call to getWith. And so we're still able to get that value, we just have to use a method call to get it. The access to unit here, though, is fine because, again, unit is a private field from the same class, and so it can be accessed directly. Now, our old version of the constructor, the one in which we did all of the work ourselves, that's not going to work anymore now that width and height are private. And so we have to go to that other version where we call the superclass constructor. And this is pretty much always the way you want to go. When you're writing a constructor for a subclass, you want to start by calling an appropriate constructor from the superclass. And it turns out Java requires that you do that as the very first line of your subclass constructor. If you're going to do it, in theory you might be able to get away with not doing it, but we really recommend that you always start by doing that.